All right, let's take a look at example 2, number 5 and 6. And over here I have the graph of f. It's connected by endpoints, connected by line segments, right? Negative 2 comma 4 is an endpoint, 2 comma 0 is an endpoint, 0 comma 3 is another coordinate, and I just labeled it A, B, and C just so we know which coordinate refers to which. All right, so we are asked to compare each of these graphs, in this case number 5, h of x, to f of x, right? So pretend f of x is now your parent function. Remember, f of x can be anything, right, for your parent function. And our job is to compare in part A, how is h different than f? Part B, we're going to use the graph of f to sketch h, and then we're going to state the domain and range. All right, so before we begin, let's state the domain and range of f. And the smallest x value I have right here looks like it's a -2, and it goes all the way up to +2. So again, I'm writing this in interval notation. I guess for the first time I went over interval notation with you guys, the homework didn't actually require it, but from here on out, I expect you guys to write it in interval notation. The range, the smallest y value, is in your c coordinate, right? It goes from 0 to the biggest y value, which is in your a coordinate, 4. Okay, so domain and range simply stated using interval notation. All right, so let's take a look at part A on number 5, right? All right, so this number right here tells you it changes the size of the graph, right? And because the absolute value of A is between 0 and 1, we say it's a vertical, you can say compression or shrink. Okay, so I think in the notes I use compression or /shrink by a factor of 1/2. Okay. All right, now this guy right here tells me I'm going to shift the graph 1 unit to the left. Remember, it's counterintuitive, right? If it's +1, you actually shift it 1 to the left because you could rewrite this as x minus -1. And then, of course, this tells you shift it 2 units up. So you could say, you could use the arrow marks, 1 unit to the left and 2 units to the right. Okay, so you don't actually have to write the words. Okay, so that's how f is being transformed. It's going to be compressed, right? It means it's going to be pulled towards the x-axis and then shifted 1 to the left, 2 units up. All right, now on part B, what do I need to do? I actually need to get the coordinates, right? And for me to get the coordinates, I need to determine what to do with my original x values and my original y values. Okay, so what is the actual process of x values and y values? What do I need to do? Okay, so the way you determine what to do with the x values is you look on the inside of the parentheses. Okay, and actually I wrote this wrong, right? There should be an f over here. So inside the parentheses, which is right here, right, it impacts my x values, right? And I already wrote down here that basically this tells us to shift the graph 1 unit to the left. So intuitively, if I'm shifting the graph 1 unit to the left, I need to subtract by 1. Okay, so that's what I do with the x. And the way you figure out what to do with the y values is you take a look on the outside. This guy right here changes the size of the graph. This guy right here shifts it 2 units up, right? And so remember, if you have a number out here, if you look at the coordinate rule in the notes I gave you, you basically take your y value, multiply by a, right? And over here, if you have a shift, a translation 2 units up, you basically add, right? And so when you have two operations, you have to multiply and add, right? You have to follow the order of operations. You need to multiply first. So what I'm going to say is multiply by 1/2 and then add 2. All right, so let's actually do that. Our coordinates for our function here for f is -2, 4, 0, 3, 2, 0. This is my A, this is my B, this is my C. And let's actually do the process or do the operation now. The x values, I subtract 1. So -2 subtract 1 is -3. 0 subtract 1 is -1. 2 subtract 1 is 1. So this is A prime, B prime, C prime. And then y values, I need to multiply by 1/2 and add 2. So 4 times 1/2 is 2. 2 plus 2 is 4. 3 times 1/2, that's 1.5. 1.5 plus 2 is 3.5. And then 0 times 1/2 is 0. 0 plus 2 is 2. Okay. And those are the coordinates. Now, we actually have to plot this, right? So for this first example, I'll plot it. In the future, I'm not, because I'm pretty confident you guys know how to plot these points. 1, 2, 3, 4, 5. Okay, so -3, 4, somewhere over here, there's my A prime. -1, 3.5, somewhere over there, there's my B prime. And then 1, 2. There's my C prime. Okay, so roughly there's my graph, right? Again, it got vertically compressed and it got shifted 1 to the left, 2 units up. And for part C, right, I need to state the domain and range of H. The domain, right, the smallest x value in this case is -3. You could just look at your table. You don't have to look at the graph. And the biggest x value looks like it's 1. And the range goes from 2 to 4. All right, so there's example 2, number 5. So let's take a look at number 6 here. G of x is equal to f of -2x minus 8. Okay, so before you begin and start comparing to the parent function of f, notice there's a coefficient in front of the x, right? The coefficient, which is -2. Whenever you have a coefficient, right, you make sure you factor it and put it in general form. So all you need to do is one step here before you even begin this problem is factor out the -2. So over here you have x plus 4. Okay, otherwise you might think, oh, this is shifted 8 units to the right. It's not, okay? It's actually shifted 4 units to the left. All right? Okay, so let's do the comparison. You have to interpret what the heck this means, right? So first things first, I have a negative inside my f of x, right? Inside my parentheses. And so that negative, since b is less than 0, it's a reflection over the y-axis. Notice you have a b value, right? The absolute value b is greater than 1, right? This -2 is your b value. And that changes the size of the graph horizontally, right? So you would say horizontal. Okay, it's not a horizontal stretch, right? It's a horizontal shrink or compression. Either one of those words works. Now here's the key. By a factor of not b, right? By a factor of 1 over b. So this is absolute value of 1 over -2. 1 over the absolute value of -2, which is 1/2. So by a factor of 1/2. Okay, so that's the wording right there is a little confusing. You don't say by a factor of b, by a factor of 1 over b. Okay, this is your b value. All right, so last but not least, right, this shifts the graph 4 units to the left. 4 units to the left. Okay, so you state those 3 things. You're done with part A. Part B, again, I need to figure out, what I need to do with the coordinates, right, with my x values and my y values. Okay, so remember, y values are impacted by anything outside, right? Anything over here, but there's nothing over there, right? And so you can just keep your original y values, okay? So the nice thing is you keep your original y values. X values are impacted by anything inside the parentheses, right? And so I have a -2 here, right? So if you look at your notes, whatever that b is, you take your x and you divide by it. And if I shift it 4 to the left, right, I have to subtract by 4. And following my order of operations, I need to divide by -2 and then subtract 4. All right, so again, take your coordinates here. Here's my x, here's my f, a, b, and c. So -2 commas 4, 0, 3, and transform. Okay, so I believe this function is called g. All right, so if the y values I'm going to keep, I'm just going to write 4, 3, 0. And the x values perform the operation. Negative 2 divided by negative 2 is positive 1. Positive 1 subtract 4 is negative 3. 0 divided by negative 2 is 0. 0 subtract 4 is negative 4. 2 divided by negative 2 is negative 1. Negative 1 subtract 4 is negative 5. Okay, so the very last thing you need to do is just plot and connect with segments. Okay, so they're not lines, they're actually line segments, means it actually stops, right? This is my A prime, this is my B prime, this is my C prime. Okay, so that's a terrible B. Hopefully you can read that. All right, so for part C, do I need to graph it to state the domain range? You don't have to graph it, right? You can actually see the table here. The domain is from negative 5 to negative 3. The range is from 0 to 4.